let us solve some of the problems regarding the scalar triple product. So in that first question, they have asked us to find vector A dot B cross C, where vector A, vector B, vector C are given. So we know that vector A dot B cross C can be represented in the determinant form, where the first row is the component of vector A, that is 2, 1, 3. Second row component of vector B, -1, 2, 1, and third row component of vector C, it is 3, 1, 2. Now I am expanding this determinant along the first row. 2, 2 2s are 4, -1, -1, it is nothing but -2, -3, plus 3, -1, -6. So it is nothing but 4 minus 1, it is 3, 3 2s are 6, -2 -5, -2 -3 -5, minus of minus plus 5, it is -7, -7 into 3, -21. So it is nothing but 6 plus 5, it is 11, minus 21, which is nothing but -10. It is the answer. So this is how we get the value of vector A dot B cross C. Next, we need to show that these three vectors are coplanar. So what is the condition to say the three vectors are coplanar? That is vector A dot B cross C, it should be equal to 0. If the scalar triple product is equal to 0 means then these three vectors are coplanar. So I'll consider the scalar triple product of these three vectors. So how we are going to write? First row, that is 1, -2, 3. Second row component of second vector, -2, 3, -4. The third row component of third vector, 1, -3, 5. So now I am expanding this one along the first row. 1, 5 3s are 15, minus into minus plus, so minus 4 3s are 12, minus of minus plus 2, so it is nothing but 5 2s are -10, minus of minus plus 4, plus 3, so it is nothing but 3 2s are 6, minus 3, so it is nothing but 15 minus 12, it is 3, minus 10 plus 4, -6, -6 into 2, -12, so 6 minus 3, it is 3, 3 3s are 9, so 9 plus 3, 12, 12 minus 12, it is 0. So we can see that the scalar triple product is equal to 0. Therefore, vector A, vector B and vector C are coplanar. So we have proved the thing. So the next is, they have given the three vectors and they asked us to find the lambda value of what is the value of this lambda when these three vectors are coplanar. So what is the condition? As I said, for the condition for coplanar, that is where scalar triple product is equal to 0. So that is nothing but what is vector A, 1 3 1, vector component of vector B, 2 -1 -1, component of vector C, lambda 7 3. So the scalar triple product is equal to 0. So now let us expand this one along the first row. So 1 of -3 plus 7 minus 3, it is nothing but 3 2s are 6, minus of minus plus lambda plus 1, 7 2s are 14 plus lambda. So which is nothing but -3 plus 7, it is nothing but 4, minus 6 3s are 18, minus 3 lambda plus 14 plus lambda, which is equal to 0 because our RHS is equal to 0. So now you can see here properly, 14 plus 4, it is 18, minus 18, it is 0, minus 3 lambda plus lambda, it is nothing but minus 2 lambda is equal to 0. It implies lambda is equal to 0. This is how we got the value of lambda. The condition was coplanar, so RHS was equal to 0. So in the LHS we have expanded the determinant and the value of the determinant is equated to 0 because of the condition of coplanarity. So the next question is, they have given the 4 points, that is A, B, C, D, and the position vectors of 4 points, that is, this is the position vector of A, point B, point C, and point D. They are asking us to show that these 4 points are collinear. So as I said in the beginning itself, during the explaining in the previous video regarding the collinearity, that is, we can show the 4 points as with the concept of collinearity of 3 vectors. They have given the position vectors of vector A, vector B, vector C, and vector D. So first we need to find vector AB, vector AC, and vector AD. Once we get these 3 vectors, with the help of these 3 vectors, we can say that we can show that these 3 vectors are coplanar. So how we are going to get, since they have given us vector, this is nothing but our vector OA, this is nothing but vector OB, this is nothing but our vector OC, and this is nothing but our vector OD. So first thing is, we need to find vector AB. It is nothing but vector OB minus vector OA. So it is vector OB, it is nothing but minus j cap minus k cap minus 4i cap plus 5j cap plus k cap. So value of this one, it is nothing but minus 4i cap minus 6j cap minus 2k cap. Similarly, vector AC, it is nothing but vector OC minus vector OA. So what is vector AC? It is nothing but 3i cap plus 9j cap plus 4k cap minus vector A, it is nothing but 4i cap plus 5j cap plus k cap. So the vector AC, it is nothing but minus I cap plus 4j cap plus 3k cap. Similarly, vector AD. So vector AD, it is nothing but again vector OD minus vector OA. What is vector AD? Minus 4i cap plus 4j cap plus 4k cap minus vector A, 4i cap plus 5j cap plus k cap. So it is nothing but minus 8i cap minus j cap plus 3k cap. So now you got vector AB, vector AC, and vector AD. So now with the concept of collinearity of 3 vectors, that is, if I show that vector AB dot vector AC cross vector AD is equal to 0. So how we can show? We need to show this one. So considering the LHS, what is vector AB? Component of vector AB minus 4, minus 6, minus 2. Component of vector AC minus 1, 4, 3. Vector AD minus 8, minus 1, 3. So expand this determinant, get while after expanding, getting the value of this determinant is equal to 0 implies that these 3 vectors are coplanar. So these 3 vectors are coplanar means all the 4 points are lying in the same plane. So expand this determinant by yourself and get the value is equal to 0. Here is another question which is similar to the previous question. Here they asked us to find the value of x when they have given the 4 points, such that they are saying that these 4 points are coplanar. So they have given you 4 points as usual. They have given you the coordinates of 4 points. The thing is, you need to find vector AB, vector AC, vector AD. We know that if 4 points are coplanar means obvious that our vector AB, vector AC, vector AD are also coplanar. When these 3 vectors are coplanar means we know that vector AB dot vector AC cross vector AD is equal to 0. So once we get these 3 vectors and that one is equal to 0 means at that time we can get the value of x. So first thing, we need to find vector AB. So they have given you the points how we can get the vector AB, that is b minus a, 4 minus 3 it is I cap plus x minus 2 j cap, 5 minus 1 it is 4k cap. Similarly vector AC, it is nothing but c minus a. So 4 minus 3 I cap, 2 minus 2 plus 0 j cap, minus 2 minus 1 minus 3 k cap. Again vector AD, so D minus A, so 6 minus 3 3 I cap, 5 minus 2 3 j cap, minus 1 of minus 1 minus 2 k cap. Now we got three vectors. We know that, as I said, 4 points are coplanar, means it is obvious that these three vectors are coplanar. So these three vectors are coplanar means what? Vector AB dot vector AC cross vector AD is equal to 0. So what does this becomes? 1 x minus 2 4 1 0 minus 3 3 3 minus 2 is equal to 0. Now expanding LHS, expanding the determinants which is on the LHS, that is 1 0 minus of minus plus 9 minus of x minus 2, it is nothing but minus 2 plus 9 plus 4, it is nothing but 3 minus 0. So what does this becomes? 9 minus here it is nothing but minus 2 plus 9, it is nothing but 7. So it is nothing but minus 7x, minus into minus plus, 7 2s are 14. Here 4 3s are 12, which is equal to 0 because our RHS is equal to 0 because they are coplanar. Now 14 plus 2 plus 9, it is nothing but 35, which is equal to 7x. So value of x is equal to 5. So this is how we got the value of x with the condition of coplanarity. So the next question, they have given you the three vectors, vector A, vector B, vector C, and in the first thing, vector A is equal to I cap, j cap, k cap, vector B is equal to I cap, and vector C is equal to C1 I cap, C2 j cap, and C3 k cap. So in that first thing, let us solve one by one. For the first one, they have given the value of C1 and C2, and we need to find the value of C3. So to find the value of C3, they are saying vector A, vector B, vector C are coplanar. So clearly vector A is I cap, j cap, k cap. Vector B is I cap. So vector C is, they have given the value of C1 and C2, that is I cap plus 2j cap plus C3 k cap. We need to find the value of this C3, and they are saying that these three vectors are coplanar. So these three vectors are coplanar means vector A dot vector B cross C is equal to 0. So it is similar to the third question, that how we find the value of lambda there. So substitute this one in the determinant form, get the value of C3. That's all regarding the first question, how to solve the first one. Second one, they have given here the value of C2 and C3, so that the vector C, what does that happens? We need to show that no value of C1 can makes vector A, vector B, vector C coplanar. That is C1 I cap, C2 is nothing but minus 1, that is minus j cap, C3 it is nothing but plus k cap. So this is vector C. So here what they are saying, no value of C1 can make vector A, vector B, vector C coplanar. So so the thing is, when we are saying the vector, these three vectors are coplanar, when we get the scalar triple product is equal to 0. So now let us find what is the scalar triple product of this vector. So our vector A, it is nothing but 1 1 1, component of vector A. Component of vector B, it is nothing but 1 0 0. Component of vector C, it is nothing but C1 minus 1 1. Now let us expand this determinant. So 1 0 0, so 0 minus 0 minus 1. So while taking minus 1, 1 minus 0, again plus 1, it is nothing but minus 1 minus 0. So it becomes what? 0 minus 1, it is also minus 1, which is nothing but minus 2. You got the value of this determinant is equal to minus 2. So you can see clearly that this expansion of determinant, this one is independent of C1. So the value of this determinant, it is not depending upon the value of C1. Suppose if you take here where C1 is equal to 2, or if you take C1 is equal to any value, you can take any value for in the place of C1, means you are going to get the value of determinant is equal to -2. There is no changes in the value of determinant if you go on changing the value of C1. So the determinant is independent of C1. So the value of determinant is not depending upon the C1. So what we can say that no values of C1, if we give any value to C1, the determinant value is not equal to 0, because if you give any value, the determinant value remains -2 itself. You can check it yourself. So when determinant value is not equal to 0, any value of C1 is not going to vary the determinant value. So there is no value of C1 can make vector A, vector B and vector C coplanar. So understand it carefully. In the place of C1, if you give any value, the determinant value is not equal to 0, because the determinant, it is independent of C1. The determinant value is not at all depending upon the C1. So if you give any value, this value remains -2 itself, which is not equal to 0. When the scalar triple product is not equal to 0, means then these three vectors are not a coplanar. So here we need to prove this one, that is vector A, vector B, vector C plus vector D is equal to vector A, vector B, vector C plus vector A, vector B, vector D. We know that this is denoting the scalar triple product. So now let us consider LHS, that is vector A, vector B, vector C plus vector D. So this can be written as vector A dot vector B cross vector C plus vector D. This is how we can write this LHS. So what does this becomes? Vector A dot, here it is vector C plus vector D, distributive property, vector C plus vector B cross vector C plus vector B cross vector D. So I multiplied this vector B with respect to two vectors, that is vector B cross vector C plus vector B cross vector D. Now I am taking the multiplying this vector A to both the components, that is vector A dot vector B cross C plus vector A dot vector B cross D. So now look clearly, what does this becomes? Vector A dot vector B cross C, it is nothing but vector A, vector B, vector C in the order, plus what does this becomes? Vector A, vector B, vector D in the order. So this is nothing but our RHS, right? We needed this itself. So this one is equal to RHS, hence proved. So there is another question similar to the above question. We need to prove this one. So I'll consider the LHS. So I can write this LHS as vector A plus vector B dot vector B plus vector C cross vector C plus vector A. This is what the scalar triple product denotion can be written in the using the dot product and cross product. So now this one is equal to vector A plus vector B as it is. Now I am multiplying this scalar triple product to each and every. So vector B is multiplied to both the thing, vector C is also multiplied to both the things. So it becomes vector B cross vector C plus vector B cross vector A plus vector C cross vector C plus vector C cross vector A. We know that vector C cross vector C is equal to 0 vector. So this becomes 0 vector. Rest 3 remains as it is. So vector A plus vector B dot vector B cross vector C plus vector B cross vector A plus vector C cross vector A, because this becomes the 0 vector. Now again I am multiplying vector A to all the 3 vectors here and vector B also to the all the 3 vectors. So what does that becomes? Vector A dot B cross C plus vector A dot B cross A plus vector A dot C cross A, where vector A is multiplied to all the three vectors. Next, now I am multiplying vector B to all the three vectors. That becomes vector B dot B cross C plus vector B dot B cross A plus vector B dot C cross A. Now, how can I write this scalar triple product in the in the representation of scalar triple product? This becomes vector A, vector B, vector C in the order. What does this becomes? Vector A, vector B, vector A. What does this becomes? Vector A, vector C, vector A. What about this? Vector B, vector B, vector C. What about this one? Vector B, vector B, vector A. Plus what about this one? Vector B, vector C, vector A. We know that if there is any two identical vectors means then the scalar triple product is equal to 0. So here you can see two identical vectors, so value of this one is equal to 0. Here also two identical vector, value is equal to 0. Identical vector, value is equal to 0. Identical vector, value is equal to 0. So what and all remaining? Vector A, vector B, vector C plus vector B, vector C and vector A. And we know that the value of scalar triple product does not changes for the cyclic permutation. So vector B, vector C, vector A, it is a cyclic permutation. So that vector is also equal to, the value of this one is also equal to vector A, vector B and vector C. So it is nothing but 2 times vector A, vector B and vector C, which is nothing but our RHS, which you can see here. Similar to the solving this question, similar to this one, there is another question, that is we need to prove that vector A, vector B and vector C are coplanar if vector A plus vector B, vector B plus vector C and vector C plus vector A are coplanar. So if this vector is coplanar means we need to prove that this vector is also coplanar. How we are going to start? I'll just give the hint. Solving part is left to you people itself. So how we are going to start? They have given that these three vectors are coplanar. So that vector is coplanar means what? Vector A plus vector B dot vector B plus vector C cross vector C plus vector A is equal to 0. So solve this one. Similar to this one, it follows with the similar way. So at the end, we are going to get 2 times vector A, vector B, vector C is equal to 0. 2 goes to that side means vector A, vector B, vector C is equal to 0. So if 3 vectors is equal to 0 means what does that implies? Vector A, vector B, vector C are coplanar. So solving of this part is similar to this question. You can do it by yourself. So this is the hint. You need to get this idea that writing this statement in the mathematical notation form. So this is regarding some of the problems based upon the scalar triple product. So try to solve it by yourself. Once you go through this video, if you have any doubts, you can ask me at any time. Thank you.